friends, welcome to GATE Academy Global. So before starting today's session, I would like to take the feedback or the concurrence regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat and then we are ready to move ahead. My dear friends, in last video, we completed the series over the engineering mathematics where taking the help of the problem which have appeared in GATE 2021, I was building the concept for the year 2022. And from today onwards, my motive is entirely different. I am going to start from the very basic part of the engineering mathematics, and slowly and sluggishly we are going to learn the crux of the engineering mathematics. So the motive which we were following in the last 14 number of videos and the motive which we will be following from today onwards is going to be precisely different. It has been clearly written, the basic curve. The topic which we are going to start in today's video, we would be discussing about the important basic curves, and the basic curve which I would be discussing in today's class is going to be logarithm. See, logarithm has been such an important function, either you are from mechanical, civil, electrical, electronics, any of the branch, but most of the time I feel the student actually does not know about the logarithmic function at all, how it looks like. If in xy plane, if I draw the log of x, how it would look like, whether it's a monotonical increasing function, monotonical decreasing function, at limit x tends to 0 plus, what would be the worth of log of x, at limit x tends to infinity, what would be the worth of log of x, why the log of x is not being defined for the negative values, similarly why log of x into y becomes log of x plus of y. There are several number of doubts that people used to have in their mind. So I am going to smash all of those doubts one by one, and definitely you had to follow my lecture sincerely and try to make the proper notes, because I am going to go from the very basic part of the engineering mathematics, which will give a basic foundation to the engineering mathematics and to your complete engineering itself. And it has been clearly written, engineering mathematics, learn from the basics. So the basic motive behind the series which we have begun from today onwards, we are going to start from the very basic or the scratch knowledge of the engineering mathematics. And as far as the branch which we will be covering within this series of the engineering mathematics, all of the branches. Either you are from electrical, electronics, instrumentation, mechanical, PI, chemical, even aerospace, there are several kinds of streams which are there within the GATE where the engineering mathematics do there inside their curriculum. Yes, it would be utterly important for all of the branch. And as the videos are supposed to come in our GATE Academy Global channel, that means my mode of communication would be in English, but nobody should get hesitant. My mode of communication would be in English, but still you are going to learn so many new as well as lucrative concepts. So I would say, whether you are the student from the zone of Hindi speaking, maybe from the English speaking, or maybe from the southern part of a country, you are going to really enjoy this complete series of the video. So till this point, probably each and everything must be clear to all of us, and I would request to any of us, the person who have been live over the concurrent viewing, they can share this session to our Telegram group. So at least the rest of the people who may not be aware that the session has been begun, they will be knowing about it. So till this point, each and everything is clear what I am saying. So the agenda must be very clear to all of us. So I would be starting from the very basic part of the engineering mathematics. And secondly, I am suggesting to all of us, whenever you are watching my lecture, have pen and copy front of you, and try to sketch all of the important graphs which I am sketching over here, and try to write all of the important conclusion of the outcome which we are going to derive over here. Yes. Anyways, without getting delayed, let me straight away hop into the working board. Yes. So the agenda behind today's video has been very precise and clear. We are going to discuss about the logarithmic function. So each one of us should be writing the heading of the today's class is going to be the logarithmic function. And yes, we would do the surgery over the logarithmic function. You will know each and individual properties, each and individual curve, how it would look like, each and everything would be known in today's lecture. Anyways, before understanding the basic concept of the logarithm, I would suggest to each one of you start with a problem from the exponent. My dear friends, if you take 2 which has been base has been raised to the power of 3. What does that has to have this result? The result used to be 8. Yes. 2 to the power of 3 is equals to of 8. May I know what's the 2 over here? The 2 is called base, also called radix, base. The 3 is exponent. That means the 2 has been raised to 3. So the 3 is going to be exponent. And 8 has been result. 8 has been result. Anyways, what the 2 to the power of 3 indicates? The 2 to the power of 3 indicates the 2 is getting multiplied 3 number of times. And yes, the 2 is getting multiplied 3 number of times. The result, what we used to have in our hand, is simply going to be 8. But this structure of the mathematical form, if we would like to write into the form of logarithm, see how we write. See here, it would be simply written as log. May I know what was the base earlier? The base was 2, no? So here also the base would get repeated. The result would come over here, and once the result is coming over here, so the power, which is nothing but the exponent, comes as the result now. Could you understand what I am saying? Earlier we had 2 to the power of 3 is equals to of 8, and if you want to convert this exponent form of the mathematical expression into the logarithmic form of the mathematical equation, what happens? The base remains base. Earlier it was a base of exponent, now it has been a base of logarithmic function. Similarly, the result do come along with the log, and similarly the exponent becomes the result now. Could you understand what I am saying? Virtually, in future, if you wanted to write log base 2 of 8 is equals to 3 in a form of exponent, what would be the change over here? Base would remain base, yes. The result would become exponent, and now the exponent which has been applied over the 8 would become the result. Yes, we are getting the same. Could you understand what I am saying? Similarly, in the same sequence, let me take two or more number of problems. If I have taken another problem, let's take, it has been 5 which has been raised to 3. That means 5 have got multiplied 3 number of times. The result, what we expect, it's simply equals to 125. May I know how will you write 5 to the power of 3 is equals to 125 into the form of logarithmic mathematical function? See what happens? Log has been a logarithmic function. We'll more be talking about its detail. The base would remain as it is. The result which is there would get applied across the logarithmic function, and the power would become result now. Agree? In the another way, if I would say, let's take log base 2 of 16, what would be the result of this? Log base 2 of 16, I would like to ask from each one of you, if I have taken a problem where the log base of 2 has been operated over the 16, what would be the result? I want the answer over the live chat. So the person who have got the result for this particular mathematical expression should be writing their answer over the live chat. See, there are 2 or 3 different methods through which it could have been taken. The first one, like we can write this as 2 to the power of 4, the 4 would come out, log 2 of 2 is 1, and by default the answer what we are getting is simply going to be 4. Yes, the answer have started coming, the answer have been 4, My dear friends, what would be the motive now? See, the base would remain as it is, the result would become the exponent, and the log has been applied over the 16, the 16 would go towards right hand side. So may I know the 2 has to be raised to a which particular value such that the result would become 16? Obviously this question mark has to be 2 to the power of 4 alone. Obviously the best most answer is going to be 4. So obviously, how many number of answers we have got it over the live chat? The 4 number of answers we have got it over the live chat, they all are perfectly correct. But yes, manually or conceptually, if you wanted to get the value of this question mark, the answer would have been 4. Similarly, let me ask one more important question. What it is? Let's take log base of, let's take 10. Not 10, because you are comfortable with 10. Let's take log base of 4 of 1. What would be the worth of it? Log base 4 of 1. Tell me what would be the result for this given problem. I want the answer over the live chat. What would be the best most answer for this given problem? Tell me what would be the answer for this given problem where log base 4 has been operated over 1. My dear friends, what does that actual mean of it? The base would remain as it is when we try to express this logarithmic function into form of the exponent. So here it becomes 4 raised to a certain question mark and the result has to be 1. May I know what has to be the power of 4? Obviously there is nothing but the question mark has to be 0 alone, 0 alone. So if I say log base 4 of 1, the result would be simply 0. Result would be simply 0. So obviously most of us are agreeing on this component. Let me go forward. And if I have moved into the next question, rather taking log base 4, if I have taken log base 6 and if it has been operated over a unity number, tell me what would be the answer. Similarly, I can take even log base of, let's take maybe 16 of 1. Tell me what would be the possible answers for both of the questions. Obviously it would be 0 as well as 0. Why? If you want to express the log base 6 of 1 into the exponent form, how has to be written this as? This has to be written as 6 has been raised to a certain question mark and the result has to be 1, and that's possible only if the question mark has been 0. Similarly here 16 has been raised to a certain question mark, the result has to be 1, obviously the question mark has to be 0. Deepak Moni sub 0, definitely. So from here, what's the conclusion we can derive, my dear friends? The conclusion which we can derive, which we are going to write as one of the important property which is getting followed by the logarithmic function is gonna be log base a, where the a could be 2, 3, 4, 5, 16, 64, 10, even exponent. If it is going to be applied over 1, the result would always be 0. Yes, each one of us would be agreeing on this moment of point. If you have any sort of doubt, you can ask over the live chat. So at least we'll have the fair idea that you guys are able to digest the outcome which I am deriving over here or not. Yes. So from here onwards, we can say log base a of 1 is already being 0. Whether it's a log base 10 of 1, log base e of 1, log base 2 of 1, because in electronics specifically, even we deal with the binary system, hexadecimal system, octant system, there the base changes from 2 to 16 to 8. So in that case, you need not to worry about a. If it is getting operated over 1, by default the result what we would be getting is simply going to be 0. So till this point, probably each and everything must be very clear to all of us. Now let me take few more number of problems, and from there we would try to retrieve few more important properties followed by the logarithmic function. See what it is. If I have taken a problem log base 10 of 10, tell me what would be the worth of it. Nobody should give the by-hearted answer. Usually we used to by-heart these values and straight away they will be giving the answer. No. Just try to go through the basic concept of the logarithmic function and try to get what would be the best most answer for this given problem. See what it indicates. The base would remain as it is. This question mark would be coming in power of base, and similarly it has to be equals to of 10. Tell me what would be the worth of this question mark. Obviously the worth of this question mark has to be precisely 1. Because the 10 has to be raised to a certain power such that the result should be matching with the 10 alone. How it's possible? It's possible only when the question mark is 1. Similarly, in the same pattern, let me take one more problem. Probably you would be able to smash this problem within a fraction amount of time. And let's take, it has been log base of e, which is also called log natural, has been applied over the e. May I know what would be the worth over here? It's precisely same as e has been raised to a certain question mark, and the value has to be precisely e. How it's possible? It's only possible by keeping question mark as 1. So from here, now it's right time to bring one more important property followed by the logarithmic function, and that is nothing but log base a of a would always be 1. It could be a problem like log 2 of 2, log 3 of 3, log 4 of 4, even log 5 of 5, so on and so forth. So that's gonna be the best most answer what we get. Yes, till this point probably each and everything must be clear to all of us. So let me move forward and bring few more number of properties as well as problem based on the logarithmic function. Agreed? Till this point probably each and everything must be clear to all of us. Each and everything must be clear to all of us. Yes. Let me move forward. What I am saying, let me move forward. What I am saying over here, just try to understand in this way. If I say log base 1 which has been applied to a certain independent variable x and the result has been y. Result has been y. May I know whether it is a appropriate expression of the logarithmic function or not? Or in another way I can say whether I can use the base as 1 or not. Just I wanted to have the answer in terms of yes or no. What I am saying, you can have a logarithmic function where the base is precisely 1. If the answer is yes, write yes over the live chat. If the answer is no, write no over the answer. Tell me, can I have this sort of problem? Can I have this problem? Tell me. Can I have this sort of problem? Yes or no? My dear friends, log base of 1 getting operated over the x is equals to of y. What it indicates? It indicates 1 to the power of y is equals to of x. 1 to the power of y is equals to of x. And keep in mind, if the y has been any real value including 0, 1 to the power of that value would always be 1. Would always be 1. Could you understand what I am saying? What it indicates, that means if you say log base 1 which is getting applied over the 2, what would be the worth of this logarithmic function or logarithmic problem? It indicates 1 has been raised to a certain power and has to get matched with 2. Whether it's possible? No, it is not at all possible. So keep in mind, I do not take the base of the logarithmic function as 1 at any moment of time. Anyways, at last we are going to summarize it. But for the time being, at least one conclusion you could have concluded over this moment of point, and that's nothing but the base of the log cannot be 1. The base of the log cannot be 1. Yes, the base of the log cannot be 1. Should I be repeating once again what I am saying? If you have taken a problem, log base 1 has been applied to a certain x and the result was found to be y. What it indicates? It indicates the 1 which was raised to y is precisely equals to of x. Yes, keep in mind, if y has been any real number, if it has been raised to power of 1, the result would always be 1. What does that mean of it? There is only one possibility of the x and that is nothing but 1 itself. So in future you may have the problem like log base 1 of 2, log base 1 of 3, log base 1 of 3, log base 1 of 4. You wanted to get the value of its result. It is an impossible expression. It is an impossible expression. So we can write somewhere here the base of the logarithmic function, base of the logarithmic function cannot be unity. No, it can't. No, the reason is in front of you. Probably I need not to explain once again this. Yes, that's the first thing. Here goes the next important thing. See, can I take log base as 0? Anyways, I am not going to frame any sort of problem. You had to frame that problem by yourself and just say yes or no. Can I be taking the 0 as a base? Would it be a permissible condition or it won't be a permissible condition? Tell me yes or no. I want the input from each one of you, the 6 number of concurrent viewers I am watching over the live chat. So obviously I expect at least a 4 to 5 number of answers from you guys. Maybe wrong answer or maybe correct answer. Tell me, can I take the base as 0? Yes or no? Can I take base as 0? Yes or no? I would be waiting for your reply. Wanted to ask, can I take the base as 0 or not? Can I take the base as 0 or not? I know many of the students just use the log here and there, but precisely they do not know what does that actually mean of log. What are the possible or permissible values of base it can have? They do not know anything about it. That is why I have started from the very scratch, and this series has been meant for that only. I have started everything from the very basic. No, the answer have come as no. My dear friends, if the base has been taken as 0, what it indicates? Let's take, I have taken a logarithmic function, the base has been taken as 0, and let's take It has been applied over the x and the resultant has been y. It indicates 0 to the power of y, 0 to the power of y is equals to of x, is equals to of x. Keep in mind, if y is not a zero quantity, if y is a non-zero quantity, let's take it's a 1, 2, 3, maybe 1.5, 1.6, 1.2, minus 1.5, minus 1.3. The 0 to raised a certain power, which is a non-zero value, would always be a zero value, would always be a zero value, would always be a zero value. That means the x cannot be anything except 0. X cannot be anything except 0. Like if I give an example, if in certain problem they have been asking to get the log which has been based on 0 of 2, what would be the worth of it? They wants to ask the 0 has been raised to a certain question mark and the result has to be 2. What is the worth of that question mark? Not possible, my dear friends. If the 0 has been raised to a certain non-zero real value, the result would always be 0. Obviously, it is a not possible expression. It is a not possible expression. So from here, one more important conclusion we could have retrieved, what it is. The base of the log function cannot be 1. Obviously, the base of the log function cannot be 0 also. So let me write over here. The base of the log function, base of the log function cannot be 0. What's the problem which we have noticed over here? Cannot be 0 over here. No, it can't. It can't. Put it inside the bracket because it has been an important outcome. It has been an important outcome. Yes, till this point probably each and everything must have been clear to all of us. To all of us. Now let me ask one more important thing. Can I have the negative base? Can I have the negative base? Would like to ask from each one of you, can I have the negative value of base? So let me focus over the next dimension of the logarithm. Can I have negative value of base? Value of base. The base has been referred as a over here. Can I have the negative value? Can I have the negative value? Would like to ask the answer from each one of you. I would expect the videos or the series of the engineering mathematics videos which are supposed to come from here onwards, it must be a sort of interactive session. So whenever I am asking any sort of problem, you must be replying at prompt most speed. So at least I'll have a fair idea that how far you guys could able to understand what exactly I wanted to say. What exactly I wanted to say. Can I have this? Can I have this? Tell me. My dear friends, if I say the log has been applied over a certain quantity x and the result has been y, may I know what is the new thing has been seen over this problem? The base has been taken negative. Base has been taken negative. See in future what is happening over here. In future it says minus 2 to the power of y is equals to of x. Minus 2 to the power of y is equals to of x. For the time being, you can take y as 2 in case x has been 4. Obviously, it satisfies this requirement. Yes, minus 2 has been raised to power of y, which is nothing but 2, obviously is equals to a 4. Till this point, each and everything is very perfect. Even you can take the next outcome. What it is, it could be like 3. And here it could be minus of 8, and here it becomes minus 2 to the power of 3 is equals to of 8 with a minus sign. Obviously here also it's very perfect, but what happens, try to understand what happens if the y has been a fractional quantity. Like for the time being it has been minus 2 to the power of y has been taken as 1 upon 2 for the time being. 1 upon 2 for the time being, the result would become an imaginary number. Imaginary number. Could you understand what I am saying? Till the value of y has been a natural number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Till that point, sir, we will cover in the engineering mathematics full course for the gate. I have had that planning in my mind. So Jinka Sivakumar is asking, sir, will you cover the engineering mathematics full course for the gate? Probably that thought process I had in my mind, I cannot assure at least in the first video. From the second video onwards, definitely I would give you the complete glance how we would be covering the complete engineering mathematics. So what is happening, for a certain prefixed value of y, the log had the base negative was a justified equation, otherwise it was a non-justified equation. Should I be considering under a proper logarithmic function? No, my dear friends. So in future, even the negative value of the base along with the logarithmic function would not be allowed. So you can write somewhere, the base of the log function cannot be negative now. Yes. So here becomes the base of the log function cannot be negative. No, it can't be. Why? Because for the all natural numbers of y, definitely it is going to satisfy the component of the exponent, but all non-natural numbers of y, it is not going to satisfy. It's not going to satisfy. So till this moment of point, probably each and everything must be clear to all of us. So from here at least I got to know few of the important conclusion, what it is. At very beginning, let me write the log which has the base of a has been operated over the x, and that would be permissible only and only when a is a positive value. That's the first thing. Similarly, and a should not be equals to of 1. Should not be equals to of 1. That means you can apply, what I am saying, you can apply the logarithmic function on any real value of x with the base a, provided the a should not be 0, it must be greater than 0, and even it should not be equals to 1. It should not be equals to 1. I have given the reasoning behind each and everything, why it can't be 0, why it can't be 1, why it can't be negative, and yes, these three portions of the a has to be left out. That means the log of x with a base a can be executed at any moment of time, provided the a has to be a positive quantity except a is equals to 1. Except a is equals to 1. Except a is equals to 1. Okay. In the same series, let me move forward. Can I have a situation like, I have taken a positive base, let's take for the time being it has been 2. Can I apply over a negative value of x? Yes or no? Whether it is a valid form of the logarithmic expression or whether it is an invalid form of the logarithmic expression. I would like to ask from each one of you, whenever I write certain problem and whenever I seek certain type of answer, you must be prompt enough to write the answer over the live chat. So at least I'll have the two-way communication and even I will enjoy my teaching more. What I am saying, whether it is a appropriate form of the expression or the mathematical expression or not. No, it is not. See, log base 2 of -1 has been a question mark. In terms of exponent, we wanted to write this as 2 to the power of certain question mark, and the result is -1. My dear friend, you can keep the question mark as a very large positive value, very large negative value, even 0, even 1, even 2, even -1, even -2. If the 2 has been a positive value and if it has been raised to a certain any possible value, the result cannot be negative. If you want, you can try over here. No, 2 to the power of -1, what would be the worth of it? It's the 1 upon 2, which is precisely equals to of 0.5. 2 to the power of -2, it would be 1 upon 2 to the power of 4, that is nothing but 1 upon 4, which would be simply equals to 0.25. And similarly, if you write 2 to the power of 2, it would be simply 4. So if you'll notice, their outcome, their all possible values has been positive alone. Could you understand what I'm saying? So from here onwards, at least you should by heart one of the important conclusion, which is getting followed by the logarithmic function. Logarithmic function cannot be applied over the negative value at all. No, it is not at all possible. Could you understand what I'm saying? If you want to have the negative value over here, what you tries to make it out of it, you wanted to have a positive value has been raised to a certain power and has to become a negative value. How it's possible? In mathematics, it is not at all possible. So obviously, the log cannot be applied over the negative value from here onwards. Log cannot be applied over the negative value. Yes. So we can write somewhere here, the log cannot be, the log function cannot be applied over the negative value. So here you can say x has to be greater than, and can it be 0? Can it be 0? What I am saying, can it be 0? No, even not. It would be yes, where the a has to be greater than 0 and a should not be including 1. So from here onwards, at least you could have got one of the very important informations, log base a of x. What are the different possibilities of the a which would be there inside the possibilities? A must be always a positive number. A cannot be 0. A cannot be negative. A cannot be 1. So you can choose either of the value, leaving negative value of a, leaving a is equals to 0, leaving a is equals to 1. Like you can have 1.5, you can have 2.5, you can have 3, you can have 4, you can 5, you can have 6, so on and so forth. Agreed. Just wanted to ask whether you are enjoying this way of teaching or not. So at least I'll get to know the new format which I have planned from today onwards, through which I would be dealing probably the major part of the engineering mathematics, whether you are liking it or not. Yes. So write down the important outcome. Here goes important outcome. Important outcome. So here goes the important outcome. Like the log has been applied over x and the result has been y. This would be a appropriate mathematical function provided a has to be a positive value except a is equals to 1. That's the first thing. Secondly, x should be greater than equals to of 0. Till this point probably each and everything could have understood. Yes. No. Now let me move forward into the same sequence of the logarithm. My dear friends, the student who are from the electrical as well as electronics or the instrumentation, whenever they calculate the gain in dBs, and even the student from the chemical, they used to study about the Bode magnitude plot. When they study about the Bode magnitude plot, whenever they calculate the magnitude in dBs, what they do? They used to take the mod before its magnitude. Why it's so important? Like if you talk about the voltage gain, how do we calculate the voltage gain? The voltage gain is being calculated as 20 log base of 10, and here the voltage gain what we have in the linear scale, we used to take its modular or absolute value. Why we do so, my dear friends? Because that voltage gain even can be positive and even can be negative, and if the AV becomes negative, my dear friends, the log cannot be operated over the negative value of the real number, and hence that is why the mod has been taken out, just to save the negative value over here. So could you understand what I am saying? So whenever we study about the analog system, deliberately I used to take this modular function just to save the mathematical requirement of the logarithmic function. Yes. So till this point probably each and everything must be clear to all of us. I don't find that any of us would have any sort of doubt now. Here goes the next important thing. My dear friends, if you have log base a of m into n, may I know what used to be the formula for it? How the expansion can be made for it? Tell me. How the expansion can be made for it? Log base a getting applied over the mn. Generally we used to write this as log base a of m plus of log base a of n. many of the times the student do have one doubt in their brain, so from where this particular outcome have come into the picture, from where this particular outcome have come into the picture. See what I am going to do over here. For the time being, what I did, see m and n, obviously they must have been the positive numbers. So m can be written as a to the power of x for the time being. Obviously it can be. It can be. And similarly, n could have been written as a to the power of x for the time being. Can be written as a to the power of x for the time being. Yes. So here I could have written this as log base a of, here it is y, you can write just a minute, y. Yes. So here it becomes a to the power of x plus y. So it has become log of a to the power of x plus y. What would be the result out of it? The result would be simply x plus y. X plus y. Anyways, what's the worth of x plus y? My dear friends, it has been clearly known that instead the a to the power of x, m has been written, and similarly instead the a to the power of y, n has been written. And if you wanted to convert this exponent in a form of logarithm, easily you can do that. See how? It would be log, base would remain as it is, the resultant would become a log of m, and result would be x over here. And similarly goes log of a, n of y, n of y. So from here the x plus y, which is precisely equals to of log base a of m plus of log base a plus of n, plus of n. Obviously from here onwards you need not to by heart this formula. So probably the student who have a well enough idea from here to here how did we approach, they would be appreciating the concept of logarithmic function even better. They would be appreciating the concept of logarithmic function even better. Similarly, the same case goes with the division. In case of division, what is happening over here, my dear friends? Again, you would be taking a to the power of x as m, a to the power of y as n. Only one difference would take place. May I know what it would be? It would be a to the power of x divided by of a to the power of y. In short, it would be x minus of y, and that plus would become minus over here, sort of this. End of the day, log of a, m by n can be written as log of a of m minus of log of a of n. Yes. So probably till this point, each and everything must be clear to all of us. See, such a huge amount of information we are reading regarding the logarithmic function, In the same sequence, let me move forward. The next important formula which we can write over here, see, log base of, let's take 2 or 3 or 4 or 5. For the time being, you can write log base b of x can be written as log base a of x divided by of log base a of b, Like for the time being, if you wanted to calculate log base 2 of 8, may I know what would be the worth? Obviously log base 2 of 8 would be precisely 3. How? The 8 has been the 2 to the power of 3, so obviously log base 2 of 2 to the power of 3 would result 3 only. You could have calculated in so many different ways. The first method could have been log base 10. You can take any of the base, no? Log base 10 of x has been 8 divided by of log base 10 of its base itself, which is nothing but 2. If you want, you can calculate from your calculator. You would be getting the answer precisely equals to of 3. Even you could have used, the format. Instead the 10, you could have taken the exponent as e. Here also the result what you would be getting, it would be simply equals to of 3. Yes. It would be simply equals to of 3. So probably till this point, each and everything must be clear to all of us. Yes. If you really want to know from where this concept have come, even you can rededuce or rederive this equation from the earlier expressions which we were deriving. Yes, you can rederive. Just take approximately 30 to 40 seconds, and I would expect from each one of you, they must be able to derive this important formula. this important formula. If you are done with this derivation, just write done over the live chat, so at least I'll have the fair idea that you could derive this equation. Log base of bx is equals to of log of ax divided by of log of a of b. Tell me, log of a of b. Yes, you must be able to derive this out. So till this point each and everything is clear? Tell me, till this point each and everything is clear or not? Probably till this point each and everything must be clear to all of us. So what I would be doing, taking the references of all of the possible formulas which we have deduced from the simplest form of the calculation, we would try to draw its xy plane curve, the xy plane curve of the logarithmic function. See what I am going to do over here, let's take, we have a logarithmic function y log base a of x, how it would look like in xy plane. For that, at very beginning, let me draw a xy plane where the vertical axis has been the axis of y, the horizontal axis has been the axis of x, and here it goes y. Yes, my dear friends, y is equals to of log a of x. Probably you may not be able to find it very catchy, but once you write this as a to the power of y is equals to of x, definitely you will have much comfortable understanding now. Just try to understand in this way. For the time being, if I have taken a is greater than 1, what I am saying, for the time being I have taken a is greater than 1. As the value of y is increasing, definitely x would increase. What I am saying, you should have the clear cut idea. For the time being, a has been taken greater than 1, and as the y is increasing, the x is also increasing. May I know in which direction the y would increase? Obviously in this direction y would increase. And in which direction x would increase? Obviously in this direction x would increase. So one thing is quite sure, as far as the a to the power of y is equals to x is concerned, or y is equals to log base a of x is concerned, it is gonna be a monotonically increasing function. As the value of x is increasing, y is also increasing. As the value of x is increasing, y is also increasing. Yes, it has to be a monotonic function. Agreed what I am saying? Now just try to understand what would be its least value, and similarly what would be its most value. Just try to understand in this way. See. For the time being, if x has been fed to be 0, may I know when the x would be 0? The x would be 0 only and only when the y is reaching towards minus infinity. What I am saying, I have taken a situation where the a is greater than 1. For the time being, you could have taken the reference of 2 itself. May I know 2 to the power of y is equals to of x, when it would lead x is equals to 0. It would lead x is equals to 0 only and only when y is reaching towards minus infinity. Could you understand what I am saying? When the y is reaching to minus infinity. 2 to the power of minus infinity, that means 1 divided by 2 to the power of infinity, that would be 1 divided by 2 into 2 into 2 into 2 into 2. That means a very large value towards the denominator side would make it 0. So one thing is quite sure, the value of y has to be minus infinity. So when the x is reaching to 0, what I am saying, when the x is reaching to 0, it can't be precisely 0. Why? Which we have already discussed over here. As the value of x is reaching towards 0, the value of y would reach towards minus infinity. Could you understand what I am saying? Should I be repeating once again? As the value of x is reaching towards 0, the value of y is reaching towards minus infinity. Yes. And one thing is quite sure, the value of x cannot be negative because the log cannot have the negative value of base. So the value of x must be reaching to the 0 plus. Till this point, each and everything must be clear to all of us. Similarly, I have taken another scenario. If the value of x has been taken as infinity, may I know what must be the corresponding value of y? The corresponding value of y has to be infinity, because if 2 is keep getting multiplied by its own value, like 2 into 2 into 2 into 2 into 2, then only it would be reaching towards a very large value. And if the y has been raised to infinity, the x would also become infinity. So one thing is quite sure, the function has been a monotonically increasing function. When the x is reaching towards 0 plus, the magnitude of y is equals to of log a x would be reaching to the minus infinity, and as the value of x is reaching towards infinity, the magnitude of y is reaching towards plus infinity. So how would be the curve? The curve is going to be sort of this. The curve is sort of this. Nobody would deny over this calculation now. Nobody would deny over this calculation now. May I know where it is trying to go? It is trying to go towards a very larger negative vertical value. Obviously, it is trying to go towards minus infinity. And as the value of x reaches to 0 plus, the magnitude of log of ax would reach to minus infinity. Agree what I am saying? The limit x tends to 0 plus, log of ax would be equals to minus infinity. And similarly, as the value of x is reaching towards plus infinity, log a of x, here it goes like limit x tends to of plus infinity. So the result would be plus infinity. Result would be plus infinity. The next thing, this is the x-axis. The x-axis is the axis where the value of y would be 0, and as the value of y has been fed to be 0, obviously 2 to the power of 0 would make it x is equals to 1. So here the worth of x would be precisely 1. Precisely 1. Or I can say x is equals to 1 is the point where log of ax crosses through the x-axis, or y is equals to 0 axis. Y is equals to 0 axis. Yes, and similarly in the same fundamental, let me move forward. Let me take the reference of x is equals to of a, and if I have taken the reference of x is equals to of a, my dear friend, what must be the value of y? The value of y has to be 1. There is no doubt as such. If the x becomes a, the a has been 2, that means the x would also become 2. When it's possible only for the y is equals to 1. Y is equals to 1. So till this point, probably each and everything must be clear to all of us. All of us. I know many of the students used to stuck over this point. Many of the wrong misconceptions they used to have, they should not have any wrong misconceptions. No, the log curve does not prevail into the second and third quadrant, because in second and third quadrant the value of x would become negative, and yes, for the negative value of x the log cannot be superimposed, cannot be applied, which we have already derived. Why can't? Why can't? Similarly, when the log of ax, when the x is reaching towards 0 plus, why I am saying 0 plus? If you go towards 0 minus, the log of ax itself is not defined. That is why I am deliberately taken as x of 0 plus. When the log of ax, when the x is tending towards 0 plus, would try to reach towards minus infinity. And similarly, when the x is tending towards the infinity plus, the log of ax would reach towards plus infinity. Log of a of x at x is equals to of 1. The magnitude of log of ax would become 0, and similarly log of a of x at x is equals to a would precisely become 1. Reverie Pranav, yes, it has been the first class. At least the way which we have started dealing the engineering mathematics from the very scratch, from the very basic, yes, it has been the first class. So let me recall what we have studied in this class, and end of the day we would be taking few number of important questions. At very beginning, what I have started stating that the logarithmic has been the another side of the coin, where we used to deal the exponent. Like we had 2 to the power of 3 as 8. What does that mean by the 2 to the power of 3 as 8? The 2 have got multiplied 3 number of times, the result has been 8. So rather writing in the terms of the exponent, you could have written this thing in terms of the logarithm. How the logarithm is being written, my dear friends? The log would remain as it is, the base would come as it is, the result would be operated over the log, and the exponent would be result now. Till this point, probably each and everything must be clear to all of us. The same thing has happened with the 5 to the power of 3 is equals to 125. So in totality, you could have written this as a log of 5. The base is very same. The result switched over here. The exponent would become result now. would become result term. Similarly here I have given few number of problem like log of 2 to the power of 16, what would be the worth? So the student have started giving the answer like 4, here similarly 0, so on and so forth. Now in the same sequence, let me focus over one more important property. I have taken a log at the base of a and has been applied over the a square. May I know what would be the simplest form of this expression? This could have been written as log base a of a. Log base a of a. Yes. Log base a of a. How it's possible? Just try to understand this. How it's possible. For the time being, what I did, log base a of a, if it is not a, you can take this as b for more larger dimension. See, log base b, which has been applied to the a square, has been taken as m. We have seen earlier, if you want to write this logarithmic function into the form of exponent, it would be equals to of b to the power of m is equals to of a square. Yes, and easily from here you can come back to this point. Come back to this point as we were talking earlier. So I would expect from each one of you, nobody had to by heart from where this expression have come out. Easily they would be able to connect this outcome from the basics of the logarithm. Yes, basics of the logarithm. Nobody should have any doubt. Agreed? So till this point, probably each and everything must be clear to all of us. If you don't understand, you can do one thing. A to the power of 2 has been taken as m. So what I am going to do over here, log base b of a, log base a of m is equals to of 2. Obviously this could have been written as log base of 2. So till this point, probably each and everything must be clear to all of us. Write down important point. Now this thing should go into the each and individual's copies. Write down the important point, and there I would be completing my today's lecture. Important point. Write down important point. Each one of us should be writing this important point. Whatever we have discussed so far, we are going to just conclude it out. What's going to be the first important point? Here goes the first important point. Yes, a to the power of m is equals to of n can be written as log base of a of n is equals to of m. It's just a way to represent the same thing into the two different format, either in logarithmic format, either in exponent or anti-logarithmic format. What I am saying, it has been the logarithmic format, it has been the log format, and it has been the anti-log format or exponent format, a log format or anti-log format. Exponent format. The conclusion which we can retrieve, the a should be a positive value alone. I think I should be writing over here only. Otherwise, many of us may forget this conclusion. A should be always a positive value, and a should not be equals to of 1. That's the first thing. Yes. And as far as the n is concerned, the n should always be greater than 0. Even it can't be 0. I repeat, log of a n has been m. Then the a has to be a positive value only, excluding a is equals to 1. Yes, that has been clearly mentioned over here, and even n has to be greater than 0. Similarly, in the same sequence, let me move forward. What it is? Log of a to the power of m is precisely equals to of m log of a of a, which we have already seen. Similarly, in the same sequence, if we write log base a of a, the log base a of a is precisely same. If the radix and the base is very same, the result would be 1. The result would be very 1. Yes. Similarly, in the same sequence, we got to know the next property, what it is. Log base a, if it is being applied over the 1, the result would be 0 precisely. Nobody can rocket it. Yes. Similarly, in the same sequence, we have taken log base a of the negative value is an undefined case. No, this mathematical equation is not a genuine mathematical equation. It is not a genuine mathematical equation. Similarly, in the next sequence, log has been applied over the multiplication between the two numbers. Let's take they have been m and n, can simply be written as log base a has been applied over the m, and similarly log base a has been applied over the n. In the same sequence, log base a of m by n could have been written as log of a of m getting subtracted with the log base of a getting operated over n. Next, log base a of m where m tends to 0 plus is gonna be minus infinity. Limit m tends to infinity, log base of a of m is equals to of plus infinity. Limit m tends to 0, log base of a of m. Tell me what would be the worth of it. I would like to ask from each one of you what would be the worth of it. Limit m tends to 0 log of a of m. It's the undefined case. If the limit has to be existed at a certain test point, keep in mind its left hand limit and the right hand limit has to be very same. That means the worth of log of a m at 0 minus and 0 plus has to be very same, my dear friends. Once you'll see its curve, the log has not been defined at 0 minus. So you can't say about the left hand limit at all. No. The limit does not exist at 0. That is why precisely I used to take the worth of the log at m tends to 0 plus. No. Similarly, log has been a monotonically increasing function. Log is a monotonic increasing function. Monotonic increasing function provided there is must a boundation, the a has to be greater than 1. Now tell me, if I have taken a situation where I had to deal with the mathematical expression log of ax is equals to of y, where the a has been in between 0 to 1. Obviously it can't be 0, it can't be 1. Mostly it used to be greater than 1, but deliberately I have taken the value of a is in between 0 to 1. What it indicates? It indicates a to the power of y is equals to of x. Yes, a to the power of y is equals to of x, where the a has been in between 0 to 1. See what is happening over here. As the value of y would increase, no, the value of x would decrease. Yes, my dear friend, just try to understand in this way. If the a has been taken as 0.1, obviously in between 0 to 1, and has been raised to 2 to 3 to the 4, obviously the x would keep decreasing. That means as the value of y is increasing, the x is decreasing. As the value of y is increasing, see. As the value of y is increasing, the x is decreasing. Yes, could you understand what I am saying? So you could have understood how the structure of this curve would be. Or in the another way you can say, as the value of x is decreasing, value of y is increasing. So in this direction, the value of x is decreasing, the y would be continuously increasing. That means it has to increase in this way. Could you understand what I am saying? Similarly, in the next step, what we are going to do over here, try to understand in this way. If you have taken y is equals to of plus infinity, what I am saying, if you have taken y is equals to of plus infinity, may I know what would be the value of x? The x would be precisely 0. The x would be precisely 0. Why? The a has been 0.1 or the number in between 0 to 1, and if it is keep multiplying with by on, like 0.1 into 0.1 into 0.1 into 0.1, obviously end of the day it would be reaching to the plus infinity. It would be reaching to the plus infinity. Put together it would become 0. It would become 0. That means as the value of x is reaching towards 0 plus, as the value of x is reaching to 0 plus, the value of y would become infinity. The value of y would become infinity. Yes, similarly, you can calculate the rest of the thing. You can calculate the rest of the thing. Tell me how the curve would be. How the curve would be. I would like to have the explanation of the curve from each one of you. I would like to have the explanation of the curve from all of you. So that would be your homework. That would be your homework. I would expect from each one of you. You must be drawing the curve for log of a x is equals to of y, which would be equals to of a to the power of y is equals to of x, where the a has been in between 0 to 1. How the curve would look like? How the curve would look like? I know many of the students would be stuck over this point. That is why this has been given as a form of the homework. Now many of the times I have seen the student used to have one doubt, sir, why the logarithmic function is so important? Why we used to read the logarithmic function at all? Yes, it's required. Yes, it's required. See how. If you must be able to recall compound interest, if you must be able to recall the compound interest. What does that mean by the compound interest? At very beginning, you would be depositing your money with certain predefined principal amount. Similarly, it would have the rate of compound interest, and similarly it would have the period of compound interest in how much span it's getting periodicity. Yes, so it has been clearly given in each 1 year the money would get compound. Let's take at very beginning you have started with principal amount of 1000 and rate of compound interest has been 10%. So may I know after 1 year, what would be the worth of your amount? So obviously 1000 rupees, and the 10% of the 1000 rupees is nothing but 100 rupees would get added with the 1000, which will make it 1100. And as it has been a compound interest, definitely from the first year onwards the principal amount would become 1100, and again the 10% has to get added over here. So after the end of 2 years, this 1100 would get added with how much? 110. So it is 110 plus 110. It would become 0, 1, 2 and 1. It would become 1210. So mathematically, if you would like to draw how much amount you would be getting after, let's take n years, how much amount would be you getting after n years? Tell me what would be the worth. The principal remained as it is. It's gonna be 1 plus rate of interest, which has been divided by the 100 and would be raised to n. Like in the first year is simply gonna be p, that is nothing but the 1000 would get multiplied with the 1 plus of 0.1, that's a 1.1. 1.1 gets multiplied with the 1000, which would make it 1100. In second year what happens? Now your principal amount has been 1100, and now again it has to get multiplied with the 1.1. How many times the 1.1 got multiplied? Obviously n number of times. And it's keep happening. Yes, it's keep happening. Now if you have been given a reverse problem, see, p has been given, r has been given, and it has been given that you wants to make your money to be compounded to maybe 2000. Then how much amount of year you had to retain your money? how much amount of year you had to retain your money. Now it becomes a very tedious problem. There is no other way. You had to solve this problem using the logarithmic method alone. See, the p has been 1000, 1000 can be shifted towards right hand side, that's nothing but 2, and here it is nothing but 1 plus r divided by 100, that is 0.1 to the power of n, and here it becomes 1.1 to the power of n is equals to 2. Tell me, how will you get the value of n? It becomes very difficult to calculate the value of n with a manual method. So what you would be doing, you would be taking ln or log natural or log base a, both are the side, and once you will do so, it would become log of 1.1 is equals to of log of 2. End of the day, easily you would be able to get the number of years which are required to make the principal amount of 1000 to be compounded as 2000. Understood? So you cannot say you are the people who are going to use the logarithmic so frequently, even the commerce people also use the logarithm so frequently, because they had to deal with the logarithmic function. Could you understand? And yes, even if I take the example of the civil engineering, during the calculation of the earthquake, they used to calculate the magnitude into the logarithmic scale. You yourself would be able to see that. For the time being, if I have taken a logarithmic function with a base of 10, at very beginning, let me take, it has been applied over the 10, the result would be 1. If it has been applied over the 100, the result is 2. If it has been applied over the 10 to the power of 3, the result is 3. If it has been applied over the 10 to the power of 6, the result has been 6. If it has been applied to the 10 to the power of minus 6, the result is merely minus 6. See what is happening over here. As far as the change in the linear scale is concerned, no. In linear scale, the change has been 10 to the power of 6 divided by of 10 to the power of minus 6, which has been 10 to the power of 12. Such a huge change it was. But after taking the log, if we'll talk about its change, the change has been from plus 6 to minus 6, and that has been plus 12. So one thing should be there in your mind, when or how and why the logarithmic function is being used. The logarithmic function compresses the varieties or the variations in the variation. Agreed what I am saying? Such a huge variation were there over the number, but now it has been shrinked to the minus 6 to the plus 6. So you can say the logarithmic function is a function which shrinks the huge variation into the data. And that is why you must have been heard, if you take the reactor scale of 5 of earthquake and reactor scale of 6 of the earthquake, there used to be a huge amount of difference between 5 and 6. Why? Because they have been 10 times. See, 110 to the power of 3 has been 10 times. While taking its log, it has just been changed from 2 to 3. That means during logarithmic calculation, the change was only unity, whereas in linear scale, the change was 10 times. So till this point, probably each and everything must be clear to all of us. One of the more best thing regarding the logarithmic function, the multiplication becomes a form of addition and division becomes a form of subtraction, and that becomes a very handy to use while calculating various of the transfer function, where the different poles and zeros has been multiplied together, and making a simple form of the expression is very difficult. So what I used to do, I used to take the magnitude here and here. Similarly, towards denominator side, I used to take the magnitude separately, and end of the day what I do, I used to apply the logarithm, and once we apply the logarithm, end of the day what we get, all of the multiplication would get converted into the addition, all of the division would get converted into the subtraction. Yes, so this is what all about the logarithmic function. So probably you would have enjoyed this class. If you have any sort of review, you can put it over the live chat or the comment. We would be meeting with the same intention, where we are going to discuss the each and individual thing within the engineering mathematics into the great detail, from the scratch, from the basics, such that you will have a very solid strength over the engineering mathematics. And once you have the solid base over the engineering mathematics, yes, you would do well into the GATE examination as well as in your technical subjects. So I would say bye-bye, take care, till tomorrow 9 p.m. We would be meeting precisely at 9 p.m. tomorrow. Bye bye. Good night.